Hello kids, welcome to EduAchievers. In today's video, we are going to continue with the same topic, that is chemical reactions. And in today's video, we are going to discuss in detail about displacement reaction, oxidation reduction reaction. We will be discussing single displacement and double displacement, both the types of reactions. Correct? Let's begin with the inspirational thought again. The thought says that start where you are, use what you have and do what you can. So there's a lot which you can do and achieve. So the thing which you need to do is just to begin or start. Correct? Okay, let's continue with our next topic, that is displacement reactions. We were discussing about these different types of reactions from our last videos. If you have not seen those videos, I will be giving the link in the description. Please go and watch those two videos so you can understand the basic different types of reactions and the combination and decomposition reactions which we have discussed earlier. Now let's begin with the displacement reaction. As the word itself is saying, displacement. That means displacement means the place of some substance or some component is changing. Displacement. Okay, in this what happens? That reactants which are involved here, the components, some of the components, the reactant changes their position. That means the general reaction which we can derive from this is that A and BC, when they are reacting together, B is displaced by A. Okay, so A displaces the B from BC compound and A attaches with that C. Correct? So this types of reaction where the components the reactant, one of the more reactive element displaces the less reactive. Hope you remember the reactivity series which I have pasted for you here, that if you can see, check the reactivity of the metals here, that which is more reactive and which is less reactive. So if the more reactive metal basically displaces the less reactive metal. So the potassium can displace the sodium, calcium, magnesium, aluminium, zinc or iron from the reactions. Correct? So the more reactive metal will displace the less reactive metal. So here also in displacement reaction, the same thing happens. Now we can also discuss that where this displacement reaction is taking place around us. Why do we need to study about it and why it's so? Correct? So we can understand that this displacement reaction is taking place in a lot of things which are happening around us. The most common we can say is in making of steel. Whenever the steel is made from the iron, then what happens? The carbon there which is used while making the alloy, which is steel, carbon displaces iron from its ore. Now remember, it is not just that this more reactive metals and less reactive metals, there are several other elements also which can displace the other metals or other elements. Fine, but this is a common thing which happens. Correct? So while making steel here, the carbon displaces the iron from its ore. Whenever we use the magnetite ore or the ore carbon, this iron ore, from that ore carbon will be displacing the iron and iron will be separated and carbon dioxide will be formed. So if we are using the magnetite ore, if it is an iron oxide which is there in the iron ore, so iron oxide reacts with the carbon and the carbon dioxide plus iron is separated. So that's how the displacement reaction are used. Second, it is also used in thermite welding, where normally it is used in joining of railway tracks. When the railway tracks are joined, then aluminium and iron oxide, Fe2O3, these two react together and this aluminium replaces the iron and this iron is separated and Al2O3 is formed. Correct? So sometimes you have to take care that there may be exceptions. Correct? So we should keep them also in mind. Fine. So this is a common. This is not in your not given in your NCERT textbook, so you don't have to remember this reaction, but it can help you in understanding things. Fine. So whenever we study about the different examples which are given in NCERT textbooks, these are the common displacement reactions which are given are like whenever this iron we normally do the activity also that we take the iron nail and put it in the copper sulfate solution, and after some time when we observe it, the beautiful blue color of the copper sulfate changes to brownish solution. So why it happens? Because this blue color of this copper sulfate changes. Why it changes? Because the iron being more reactive displaces the copper from copper sulfate solution, and the iron sulfate and the copper is separated. So the iron sulfate has a different color, brownish color, so the blue color fades away. Fine. Here you can see here that as iron is more reactive than copper, so here this iron is displacing the copper and it is taking its place. So this type of reaction is called as displacement reaction. The second one which we can take is whenever the zinc reacts with the copper sulfate. Again here also zinc being more reactive than copper, it also displaces copper and it forms zinc sulfate and copper is separated. Same here also, the lead, when this lead reacts with the copper chloride, then what happens? Lead chloride is formed and copper is separated. So these are the different or the common displacement types of reactions which we have to study according to NCERT. Now taking further the second type of reaction, that is double displacement reaction. Now what is double displacement? As the word is indicating, double means two or more. So here minimum two substances or the components are changing their position or they are being displaced in the reaction. So the general reaction for the double displacement which we can derive is that A, which is a positive ion cation, and this AB component has these two subcomponents. Correct? For example, when we talk about HCl, so H is positively charged and Cl is negatively charged. You are aware that. Correct? So similarly, when AB, which is having positive charge A and B is negatively charged, reacts with the X and Y, which are positively and negatively charged components, they are also there in that. When they both changes their places, here now you have to understand, either the anion will change its place or the cation will change its place. Now what are cations? The positively charged ions are cations and negatively charged ions are anions. So here the A is a cation and X is a cation and B and Y are anions. So you can change the place of either cations or anions. In both the ways, it is a double displacement reaction. Correct? The more general reaction which we can talk about, that where this double displacement is taking place around us. So the most of the neutralization reactions, the reaction between the acid and base, they are double displacement reactions. So it's easy to learn them. Correct? So the neutralization reaction, if I take a simplest reaction here, then if whenever the HCl will react with the NaOH, that is Na is positively charged and OH, that is hydroxide ion, is a negatively charged component in these two. So here you can understand this H plus ion and Cl minus ion is there, then Na plus and OH minus ions are there. So they will change their places, they will shift their places. So here the H reacts with the OH and it forms, you can see this H attaches with the OH and form the water, and this Na and Cl joins together and they form the NaCl. So here this is how you can see that both the two components have two parts of that reactants have changed their position, and that's why that is called as double displacement reaction. The reaction which is discussed in your book is this one, that whenever the sodium sulfate, this Na2SO4, now remember here, whenever you have difficulty in remembering the chemical formulas, remember you need to learn the valency first. You can understand here SO4 minus, this is sulfate group. Sulfate group has -2 charge, correct? So, and the sodium has 1 electron only extra, so it is have a +1 charge. So this sodium has +1 charge. So 2 sodiums will attach with the sulfate group, because the sulfate group, this SO4 group has 2 negative charges, correct? And this sodium has +1 charge on it. Same here, This barium has 2 plus charges. This has 2 positive, this is positively charged, 2 plus charge, and chloride ion is having only 1 negative charge. Correct? That means it needs to receive only 1 electron to attain a stable configuration. So remember the valency of the components, the different ions, so that you can form the formulas by yourself. Correct? So whenever we are talking about sodium sulfate, you should know the valency of sodium and you should know the valency of sulfate. You will be able to form the formula by yourself. Correct? So whenever this sodium sulfate and barium chloride react together, barium sulfate is formed. Here you can understand again, this barium has changed its position. It has come to react with the, attached with the sulfate, and barium sulfate is formed, and this sodium chloride, the sodium has come to attach with the chlorine ion, and it is forming the sodium chloride compound. So this is where you can see here we were having these all ions. We were having Na plus ion, which is having 1 charge, barium ion, sulfate ion, and chloride ion. Correct? So these all ions were formed. These 2 are cations and these 2 are anions. Anions means the negatively charged ions and cations means positively charged ions. Correct? And there's one more thing, if you have observed in this reaction, there is this plus sign which I have drawn here. This downwards arrow which you have seen here. If you remember, we have discussed in that when we are talking about the steps to write the chemical reaction, whenever a solid precipitate forms which settle down at base, we always show it by a downward arrow. So you can understand that along with this double displacement reaction, this reaction is also a precipitation type of reaction. Correct? So this is also a precipitation type of reaction. Here why we are saying that any reaction in which any precipitate, or what is precipitate? Any insoluble solid, the solid which is formed during that chemical reaction, which is not soluble in that solution, that will be called as precipitate, and we call it PPT in short. And that type of reaction in which these PPTs are formed are called as precipitation reactions. Okay, let's study the next about the oxidation and reduction reaction. These are again the type of reactions which are 1/3. These oxidation reduction reactions are comprising 1/3 of the total reactions which are taking place around us. So you can understand how common these oxidation reduction reactions are, and which we also call them as redox reactions. If you remember, in Re from reduction and OX from oxidation, so we are also calling them by redox reactions, and in other words, oxidation reduction reactions. Now, before we move further, let's understand that what these two involve. Basically, in other words, we can say that there is a transfer of electrons between the reactant. Correct? In other words, we can also define the oxidation like oxidation, as the word is indicating. Oxidation means relate with the oxygen. Okay, oxidation, that means addition of oxygen to that substance. Okay, or removal of hydrogen. When the hydrogen is removed or oxygen is attached, that is oxidation. And in terms of electrons, what we can say about it, that this is a reaction in which an atom or groups of atoms which are taking part in that reaction, they lose electrons. Okay, what they are doing, the oxidation is a reaction in which the reactants lose the electrons. Okay, so here you can understand whenever the iron will be reacting, whenever the iron will be oxidating, in terms of losing the electron, Fe3 will be formed and one iron will be given to some other ion. Correct? In formation of a compound. So oxidation involves first either addition of oxygen or removal of hydrogen or losing an electron. Correct? And what is reduction? Reduction involves addition of, here it was addition of oxygen, reduction involves addition of hydrogen. So it is quite opposite to oxidation, you can understand. So reduction involves addition of hydrogen or removal of oxygen and accepting the electrons. just opposite of oxidation is reduction. So if you remember oxidation clearly, you can just make it the reduction easily, correct? So you can understand that reduction involves gain of one or more electrons. So whatever this, for example, this iron is giving the electron, giving away the electron, and chlorine is the one which can receive the electron. So fine. So here you can see that chlorine is getting reduced because it is accepting the electron, correct? Here, if the iron may be reacting with the oxygen and combining to form iron oxide, that will also be called oxidation, correct? We are taking few more examples of this oxidation reduction reactions. Okay, but before that, let's study that where this is again used in our daily life. First one, corrosion. What is corrosion? Whenever any metal reacts with the oxygen and water in the things around us, in the atmosphere. Second is the rusting of iron. Whenever the iron rusts, it is also the redox reaction. That means one component will be reduced, the other will be oxidized, and that's why we call it redox reactions, because whenever one will be giving, then only the other can receive, correct? So they both takes place together. One gives away the electron, the other receives the electron. From one component the oxygen is removed, the other attaches with the oxygen. From one component the hydrogen is removed, the other attaches with the hydrogen. So these both reactions takes place together. Fine. And the next thing is whenever burning of any combustible substance takes place, that is also redox reaction. The next thing which we can say is whenever the color faded, whenever the color fades from our clothes, correct, that is also due to the oxidation reduction reactions. Or we can also say sometimes if you will see that the snacks, the namkeen which you have kept in your house from a long time, its taste changes. Why there is a change in the taste? Because the oil from which it is made up of, or the ghee from which it is made up of, has reacted with the oxygen and has got oxidized. So this rancidity is nothing but the oxidation of oil or ghee. So this is a common phenomena which we can see around ourselves. Now, this was around ourselves. Let's look around ourselves where this is taking place in the living organisms. So whenever we talk about living organism, the respiration is also one of the redox reactions. The photosynthesis is also one of the redox reactions. Fine. So you can understand now this redox reaction is not just in the books or not in the factories only. This is all around us. In so many processes, this redox reaction takes place. Correct? The next thing which we need to talk about redox reaction is the common examples which are given in your book. Fine. So whenever we talk about the common examples of this, we can take this first example. Whenever the copper reacts with the oxygen, copper oxide is formed. This is also an oxidation reaction. Fine. You can see that this is a addition of oxygen. So this is oxidation reduction. The next one is when this copper oxide reacts with the hydrogen gas which is passed over it, then what is happening here? This hydrogen is getting oxidized. This hydrogen is getting oxidized. It is combining with the oxygen here and they both are forming the water. So this hydrogen is getting oxidized and forming water, and this copper oxide is getting reduced because the oxygen is being removed from it. So this copper oxide is getting reduced and this hydrogen is getting oxidized. So this copper oxide is getting reduced into copper only and this hydrogen is getting oxidized into water. So this way we need to understand that oxidation and reduction is taking place together, and that's why we call them redox reactions. Correct? Then another example which we can take here is this zinc oxide and carbon. You can see here the carbon will attach with the oxygen here and will get oxidized. So the carbon is getting oxidized because oxygen is attaching with it and it is forming the carbon monoxide, and this zinc oxide is getting reduced into zinc only. So this zinc oxide is getting reduced to zinc. Fine. Okay. Now let's lastly discuss about the last reaction, oxidation reduction reaction. You can see here this manganese oxide, when it reacts with the hydrochloric acid, this manganese oxide reacts with the hydrochloric acid. Here that you can see here, manganese ion will be there, then oxide ion will be there. This will react with the hydrogen ion and chloride ions, and this manganese chloride plus water, this hydrogen will react with the oxygen and form water, plus the chlorine gas will be evolved. So you can understand that whenever there is oxidation reduction, they are they occur together, and that's why we call them as redox reaction. That is for today. If you like the video, subscribe it and share it with your friends. If you have any question, you can leave in the comment. If you have any suggestions, please leave in the comment, and keep watching, because I'm going to cover the whole syllabus and will also help you in preparing for your examinations. Thank you for watching. Take care. Stay healthy. Stay happy.